All right, so we are going to talk about an historical or a brief introduction to blockchain and cryptocurrencies. In this aspect, we have to talk how Bitcoin started and how that idea turned into a blockchain and so on. But in order to do that, first we have to mention what crypto means, okay? Because nowadays people are using the word crypto in the wrong way. So this is the main course content. We are going to cover almost all of them and maybe some new topics. So as you can see, there are the first part will be about cryptographic concepts like cryptographic hash functions on elliptic curves, digital signatures, multi-signatures, and so on. Then we are going to talk about cryptocurrencies, alternative coins, NFTs, and so on and so forth. So let's start with the word crypto. So cryptographers are not happy with how we are using the word crypto, because when people say crypto, they also immediately think about Bitcoin or Ethereum. But actually, crypto is the short of the word cryptography, and cryptography is something else. So, you will see a lot of stuff, and from this newspaper news, you can see that they are changing the name of a stadium as Crypto Arena. But it has nothing to do with cryptography, but cryptocurrencies. Okay, but don't forget that the word crypto means cryptography. But I mean, maybe 10 years ago, when you Google crypto, you will see our top conference in this area, crypto, that is maybe performed more than 30 years or 40 in Santa Barbara, United States. But nowadays, when you Google crypto, you will see the prices of Bitcoin and Ethereum and so on. All right, let's start with the short history. So the internet and cryptography made electronic money possible because now we are connected, we have connected devices, and cryptography allows security. So people thought that maybe we can have electronic money instead of using cash or credit cards and so on all the time. Maybe we can do this by, with the software, with cryptography and so on. And there were some desired properties. For instance, of course, not all of these properties are requested by all of the proposed methods, but they are like no need for a central authority. So in a banking or in a credit card, there's a central authority, and they are the ones who are checking the correctness of the transactions. And when you try to pay something, the credit card company checks if you have enough budget for that and so on. So one desired property was to have no need for central authority. Another property, of course, preventing double spending. This is important because once you are moving from physical to software, the virtually created money can be spent twice, right? If you don't do things correctly. So this is one of the main problems of electronic money. A lot of proposed methods actually collapsed because people found some bugs and spend the same money more than once, and this way companies get bankrupt and so on. Third properties provide anonymity. This is something we also want because Cypherpunk community really wants this to happen because they are not happy how the things are currently working, because you're giving all your personal private data to these companies, banks, and credit card companies, so they can actually look at your credit card transaction and learn a lot about you. So we wanted to have a anonymity so that for instance, I don't want a junior bank personnel to look at my credit card transactions and see at which place I ate pizza at that day. Okay, so this is important. And another property is allowing offline payments. So think about this like cash, on a place where there are no internet, no phones, and so on, you can pay with cash, right? You don't have to be online. But with electronic money, this is a hard thing to satisfy. Actually, there are some methods that do that, like blind signatures and so on, but our current cryptocurrencies like Bitcoin and Ethereum doesn't allow this. But they actually, Bitcoin solves the other problems. So in the Bitcoin, we don't need a central authority. It prevents double spending, and it provides pseudo-anonymity. But there are cryptocurrencies that provide full anonymity using zero-knowledge protocols, which we are going to see at the end of this course. Okay, but of course, Bitcoin does not allow offline payment. You have to be connected to a network of users and, you know, share your transactions and so on. So almost every e-cash company failed until the invention of Bitcoin. So between 1990s to 2008, there were a lot of companies just created for, you know, having electronic money and so on, or maybe electronic gold. But at the end, they all get bankrupt. Only PayPal remains, but PayPal is just a, you know, take the money from your credit card, stores it, and then transfers to the other end of the transactions. So it is not like that kind of electronic money we're talking about. So, but other companies got actually bankrupt. So Bitcoin succeeded, and this is why we are talking about it today and using it. So let's look at how Bitcoin solved this problem. So it was proposed by Satoshi Nakamoto in 2008. You can find the white paper from here. So of course, we don't know if this name was fake or not. Most probably it is not a real name of the person who found this. And actually, we don't know if it was a one person or a group of persons or, you know, secrecy agencies and so. But somebody proposed this. In 2008, exchange ideas with the Cypherpunk community, you know, learned a lot from them and used cryptography in a correct way. And at the beginning of 2009, we have the Bitcoin blockchain, and people can this way start sending Bitcoins to each other and so on. So it is decentralized. So we don't have a central authority. Every node in the network keeps a copy of the ledger. So you can think about this part as like a torrent where you share files, right? So in the system, you share the transactions, but everybody keeps all of the transactions in their ledger. So this is the main idea. So this is also different from how our banks work. So in a bank, they keep the record of every transaction in a database, but we cannot ask them, right? So you cannot go to a bank and ask the account transactions of somebody else, right? They wouldn't tell you. So this is what the central authority means in this sense. So in the scenario, we have the ledger, and it is shared with everybody. So everybody can download the Bitcoin blockchain. And from starting of 2009 to this second, you can see which accounts transfer to money to which accounts, okay? So all accounts and transactions are public. So once I say that, people are surprised because people thought that, you know, since it is cryptocurrency, they think that it has something to do with encryption. So they thought that everything is encrypted there and we cannot see it. But now I'm saying that you can see all of the transactions, all of the accounts, and see how much Bitcoin an account has and so on, and where they received it from and so on. So this means that there are no encryption. So this might be a huge surprise for you. Bitcoin, Etherum, or similar cryptocurrencies actually have no encryption at all. So this is why people actually are using the word crypto in a wrong way, because here we are not saying that crypto is identical to encryption, because cryptography has a lot of solutions, a lot of primitives, and we are going to use other cryptographic algorithms other than encryption. So let's see how Bitcoin solves this. So since everybody is keeping a copy of the ledger, they have to be synchronized and identical, right? So somebody shouldn't be able to change their ledger and say that this is the correct one. So we actually provide the integrity of the ledgers by cryptographic hash functions. So this is one of the reasons why we call them cryptocurrencies. Okay, so we don't use encryption algorithms. We are using cryptographic hash functions, like probably you heard hash functions like SHA-1, SHA-2, and SHA-3, or older ones, broken ones like MD4, MD5. And of course, some people in Turkey, for some reason, think that hash functions are encryption functions. No, in an encryption function, you have the plain text, you encrypt it, you obtain confidentiality, send it to another person, they decrypt it back, and this is what an encryption is. Hash functions are not like that. So SHA-256 is not an encryption function. And I said this maybe for the millionth time, but I still see academic papers saying the otherwise. Okay, another problem Bitcoin solved, as I told you, was the prevention of double spending. So since everybody is keeping a copy of the ledger, for instance, I want to send 1 Bitcoin to a person, so I announce it. So let's assume that everybody wrote it to their ledger, but some of them didn't. So for those people who keep the ledger and didn't write that transaction there, I can also tell them that I'm sending that Bitcoin to somebody else actually. So this causes actually a conflict, because in the network, some of the nodes keep a ledger where I'm sending that Bitcoin to person A, and in the other one, I'm sending that Bitcoin to person B. So this shouldn't happen. This is actually what we call a double spending. I have 1 Bitcoin, but it looked like I sent it twice to 2 different people. So in order to prevent this, Bitcoin introduces a slowing down operation, saying that whenever we hear a transaction, we are not writing it to the blockchain. We are actually keeping in the memory, in all of these nodes. So once somebody solves a hash puzzle, again, it's coming from cryptographic hash functions, where we are going to talk about a lot when we talk about mining. So the person who solves that puzzle actually includes all of the transactions they heard. So in that list, if it appears like that I'm sending that Bitcoin to person A, then that is the real transaction. But if that miner actually heard that I'm sending that Bitcoin to person B, so miner will write it to their list of transactions and solve the puzzle with that data. So in everybody's ledger, it will appear like that I'm sending that Bitcoin to person B. Okay. So since we are talking about transactions, this actually requires authentication, because if I want to send 1 Bitcoin to somebody else, I have to prove that that Bitcoin actually belongs to me, right? So this is done by digital signature. So whenever I create a transaction, I actually sign it with my private key, and people will check the correctness of that signature by using my public key. And again, here we are using cryptographic algorithms, digital signatures. And some people might say that, isn't this an encryption? No, digital signatures are not encryption algorithms. Again, we don't have encryption, but we have cryptographic algorithms like hash functions, digital signatures. But of course, there are more cryptographic algorithms coming into play day by day. So in the Bitcoin, we have pseudo-anonymity. So account numbers are cryptographically obtained. So actually, we are hashing your public key. So that is your account number. And it does not contain any personal information. Okay, so people who see your account number actually don't know who that account belongs to. So this is why we call it pseudo-anonymity. So here I said that all of the transactions are public, all of the accounts. So when you look at the blockchain, you will see which account number receives what amount of Bitcoin from whom and so on, but you don't know whom those accounts belong to. So this is why we call it pseudo-anonymity. But of course, since the invention of Bitcoin, it was an open question if we could provide full anonymity. So can we create a cryptocurrency so that, when you look at the transactions in the blockchain, we wouldn't understand who is sending a cryptocurrency to whom and at what amount. So it was actually thought that it is impossible, but actually this is solved by zero knowledge protocol. So today we have cryptocurrencies that actually provide full anonymity. Of course, this is a good thing for your privacy, but governments are concerned because this also can be used for money laundering. So this is why it is not actually that much used in practice, and because people are cautious, it raises a red flag if you use that kind of transactions in that kind of cryptocurrency. So we don't have it in Bitcoin, but we have zero knowledge protocols used in some of the other cryptocurrencies. So as you can see, we are using many cryptographic algorithms, cryptographic hash functions, digital signatures, and zero knowledge protocols, but no encryption. All right, so it was to give you the main idea. Now that we have the basics, let's see how a blockchain actually is created. So let's look at the basic picture of a Bitcoin block. So we call it a blockchain because we have blocks and they're connected to each other. So a block contains block data and the block header. Okay, block data is all of the transactions that are included in that block. So I told you that whenever you want to actually make a transaction, you announce it to the network, and they keep it in their mempool. But once somebody solves a cryptographic hash function, hash puzzle, so this means that that new block is written. So all of the transactions that miner heard are actually included here, and actually this zero transaction is for themselves. So here actually they are rewarding them by solving the puzzle. So in this transaction, they are actually sending the Bitcoin reward to themselves. Initially, it was 50 Bitcoins, but every 4 years, it is halved. So here, this is called Coinbase. The miner sends Bitcoin to themselves, then includes all of the transactions they heard. And so this is your block data. Then they take the hash of all of these transactions. So this transaction data can be hundreds of bytes or a few kilobytes, but hash output, once you use a hash function like SHA-256, which we are going to see in the following weeks, it produces a short output, a fingerprint, let's say, which is 256 bits, okay? So if you do this, then pair them 2 by 2 and take their hash also, you actually are creating a Merkle tree. So at the top, there is a single hash output, 256, and that is actually kind of provides integrity to all of these transactions. Because if somebody claims that this transaction tree is actually something else, the hash of this hash tree changes. Since you are changing the input, the output changes, and it also changes this value, and it also changes the Merkle root. So this way you are actually providing the integrity. So once you take miners are trying to take the hash of all of this data and try to obtain an output which starts with many zeros. So once somebody can do it, this block is finalized, the hash is written into the next block, and we're going to, try to record the new transactions to this block. So this is the idea behind blockchain. Okay. So it started with Bitcoin, but nowadays we can use this idea in many other scenarios. So here's the first block. It's called the Genesis block. Since you are chaining blocks, it has to start at some point. So this is generated by Satoshi. This is the reconstructed block from there. So there are some data, as you can see here, and this part actually contains some secret information. So if you take it, I think starting from here, if you put it into hexadecimal to ASCII converter, if you take all of this block data and write it here, you will see that there is a secret message here saying that the times 3 January 2009, Chancellor on brings of second bailout for banks. So here actually Satoshi is giving two messages to us. This happened here actually this news about about the bankrupt in 2009. So United States had to use tax money to rescue some of the banks. So here actually he is showing that why he actually creating a Bitcoin, because the main idea by the Cypherpunk community is that since countries can introduce as much of money as they want. In the past, you have to have enough gold reserves to do that. Nowadays, you don't. So they said that, you know, we cannot trust them. So this is why we should create our own currency. But the second message here is that the day he created the Genesis block is the same with this newspaper article. So it says that he really created that block that day, because he could actually did the following. You know, he could start from the Genesis block, mine all of the blocks, for instance, reach the block 12, and then announce the Genesis block. And while people are trying to mine that, he could, since he already created all of these blocks, he can, you know, introduce them in a timely fashion and obtain all of the rewards to himself. So he could pre-mine. And this technique is actually used in practice. Some alternative cryptocurrencies do that. They pre-mine their cryptocurrency, so they start with some, you know, initial cryptocurrency, and then they announce it. Here, Satoshi is showing that he is playing fairly. So let's talk about a little bit about specifications. So Bitcoin, as you can see, we had blocks here. The block data is limited by 1 megabyte. But due to some updates since 2017, this is actually virtually 4 megabyte, because we are not, the signature sizes are really big, and that's actually one of the reasons that fill this 1 megabyte. But after this update, you know, we took that signature data outside of the blocks. This is why you can actually have more than 1 megabyte of data in a Bitcoin blockchain block. So block size keeps increasing since people are introducing new transactions. And starting from 2009 to a few weeks ago, the Bitcoin blockchain size reached to 458 gigabytes. So you can download it into your computer, because, you know, we have more than terabytes of hard drives, so you can easily download all of them and, you know, check all of the transactions by yourself. This is really important, because if you don't create a blockchain in this way, if the size doesn't increase linearly, but, you know, maybe exponentially or in a polynomial way, then it will exceed a few terabytes in a short time. But in order for this kind of blockchain to work, everybody should keep the copy of the blockchain, the ledger, right? So if it exceeds a few terabytes, you know, this means that you cannot download it into your laptop or in your desktops and so on, because you have to buy, constantly keep buying new hard drives and so on. So this is why Satoshi actually calculated this in the white paper. You can see this is why it is done in a proper way. And for some cryptocurrencies, this will be a problem. One example is Ethereum, because people putting a lot of smart contracts, and, you know, unused smart contracts will keep space. So in the following updates in the Ethereum, actually they will divide the blockchain into two and keep the unused smart contracts in another hard drive, but the main transactions on the main drive, and keep them in the memory so that they can perform in the transactions in a fast way. Otherwise, you know, it will take long time to verify a transaction and so on. So some cryptocurrencies will solve this problem with new updates. But also this is important because a lot of people are introducing, writing academic papers saying that we can use blockchain for this and that, but they never calculate how big the blockchain will be in a few months. I've seen some examples where I showed them, if you really do this, you know, your blockchain exceeds 1 petabyte in 3 months. They didn't even thought that, you know, how big the blockchain will be. Okay, I told you that there is a slowdown process. So every block is written to the blockchain approximately in 10 minutes. This is determined at the beginning by Satoshi. So even if there are new miners coming into the play, this 10 minutes is tried to be kept constant. The total amount of Bitcoin is 21 million. Again, this is determined by Satoshi. And currently, more than 19 million is in circulation. So miners actually mined the huge part of this 21 million. And this is because initially the mining reward was 50 Bitcoins. So in 4 years, after the introduction of Bitcoin, we actually mined half of this Bitcoin, right? 10.5 million. So after that point, the reward is halved. So instead of 50, the reward became 25. 4 years later, it became 12.5 and so on. Currently, it is 6.25. But around March 2024, we're expecting that to be halved again. So it will be 3.125. Yes, the award halving is for approximately 4 years, but at the end of this 4 years, new miners, join, and actually it takes a little bit less than 4 years. For instance, this last halving occurred in May, but 4 years later, so it was 2020 May, but 4 years later, we are not expecting it to be May, but most probably around March. So these are the initial specifications of Bitcoin, and if you change any of these, it causes a hard fork. You can think of hard fork as a parallel universe, because if at the next block, if I change, for instance, this 10 minutes to 8 minutes, then the people who are using this change will be actually working on a different blockchain, and people who are using the older specification will be working on a original blockchain. So this actually happens most of the time intentionally. You can create your own cryptocurrency saying that starting from that block, we will change these values and we will turn it into a new cryptocurrency. And this happened a lot, actually. But you can do small modifications like adding a cryptographic algorithm, which happened to Bitcoin in their last update last year. So they actually added a new signature algorithm, Schnorr signature, so that creates a soft fork. So soft fork means that if you don't update your software, you will still understand what other nodes are talking about, which have the new update, okay? Okay, so let me talk also about this double spending. So I told you that there are miners, so they are actually trying to, take the hash of these values. In Bitcoin, you take actually double hash, double SHA-256, and try to obtain an output that is smaller than a target value. So that is what actually mining is. So idea is to find a hash value that is smaller than a target value. This is called proof of work. So initially, people did this by their CPU cores, because in 2008, there weren't GPU computing wasn't that popular. There weren't any specific hardware, so people used their CPU cores to perform the mining. But later on, GPUs become useful in scientific computing, and they can handle parallel computations in a fast way compared to CPUs. So since you are trying to obtain a value less than a target value, you can use all of your GPU cores to do that. So this is why CPUs become useless in Bitcoin mining. Then Bitcoin prices are increased, and people thought that maybe we can create a dedicated hardware that only performs this double SHA-256 operation and solve this mining problem. So once you build a specific hardware, your CPUs and GPUs cannot compete with them. So currently you can only mine Bitcoin using dedicated hardware. But since the number of dedicated hardware increased, your power became somewhat negligible in the system. So in order to solve this problem, miners join together, and this is called a pool. So instead of working for yourself, you work for the pool. And once anybody in that pool solves the hashing puzzle, the owner of the pool actually divides the reward between the miners depending on their mining power. So they provide that they are working by providing hash values. slightly larger than the target value. This is how you prove that you are actually using your hardware to solve that problem. So this actually leads us to the electricity consumption. Bitcoin mining yearly electricity consumption at some point exceeded 200 terabytes. Currently, it is smaller than this because when the Bitcoin prices dropped, some of the miners stopped mining. And this is actually larger than most of the European countries. And Ethereum was also around 100 terawatts, but I'm saying was because starting from September 2022, Ethereum changed their consensus algorithm. So instead of proof of work, they're now using proof of stake, which actually consumes negligible electricity compared to these values. But we're not expecting such a change in Bitcoin in the foreseeable future. Okay, so this is how mining, and this is how it is actually criticized, but gold mining also, causes electricity consumption around this value. So this is not that surprising. I mean, if you think about banks, they have a lot of personnel, a lot of branches, a lot of ATMs and so on. They also consume a lot of electricity. So this is not that bad, in my opinion, if it is not going to increase linearly. Let me also show you an example of a Bitcoin block. So if you don't have to download the whole Bitcoin blockchain to see the transactions. There are web pages for this. So I randomly selected a block last year or 2 years ago. So as you can see, the hash value here in hexadecimal start with a lot of zeros. So if you convert it into bits, every zero here actually represents 4 bits. So there are a lot of 0 bits at the beginning. This is the value obtained by the miner. So it shows that there are more than 3,000 transactions included in this block. Okay, the block number is this one. Difficulty actually determines how many zeros you need in the beginning actually. The Merkle root is here. Version is, we are going to see that, but actually shows which software the miners are using. So this way, when you want to update the Bitcoin, we will see how many people are adopting it. So size, as you can see, this is larger than 1 megabyte. This is due to an update that I mentioned. And in this block, more than 27,000 Bitcoins are, change hands. And the reward, as you can see, is awarded to the miner. But these transactions also have some transaction fees, as written here. This is very small value compared to this one, but again, it is hundreds of dollars. So the miner actually receives this reward and also these fees. So the sum of this value is the value that is obtained by the miner.